Hi there. So I've done tutorials in the past looking at basic hotspot mapping within QGIS, but I was recently asked the question of whether it's possible to create statistically significant hotspots within QGIS, because the typical kernel density mapping, it allows us to visually analyze the hotspots, but there's actually no statistical procedure as such behind it to determine whether they're significant. And the answer to that is yes. There is helpfully a plugin that's been created for QGIS that allows us to calculate statistically significant hotspots. So if we go to plugins, manage and install plugins, and type in the word hotspot, then you'll see this hotspot analysis plugin. Now it's worth noting that this is an experimental plugin. So actually, if you don't see that when you first type it in, you need to go down to settings, make sure you've ticked the box to show also experimental plugins, and then once that's ticked, go back and search, and the hotspot analysis plugin should appear. Now, there we go. One of the problems with this being an experimental plugin is that there's actually a few steps involved in the initial installation. If I just hit install at the moment, then you'll see I get this error message that pops up linked to there being no module named PySal. And basically the reason for that is that we need to firstly install some dependencies outside of QGIS and then also tweak those to overcome an error that tends to pop up. So I'm just going to uninstall the hotspot analysis plugin for now. So there are some tips on the homepage. So if you go to the plugin homepage, however, I've kind of found I don't follow this quite exactly, but I follow most of what it says. So if you look at the homepage and the README file, the first thing it says is about installing dependencies. So you'll need to have admin rights on your machine to be able to do this, because we have to run the OSGeo4W shell as an administrator. Now, regardless of whether you've installed QGIS using the OS4Geo installer or done the standalone installer, you should still have the OSGeo4W shell installed somewhere. And generally you can find it just by, if you're on Windows, going to your start menu and typing OSGeo. Now I've got several versions installed, so you may well only have one, and I'm actually going to use this one at the moment. So to open it as an administrator, we need to right click and open file location, and then right click on the OSGeo4W shell here and run as administrator. Yes. And then, excuse me, what I'm going to do is actually copy and paste the lines from here. So you don't need the dollar symbol, that just indicates that it's a comment and shouldn't be run, whereas we're going to run it. So first thing, is to run that py3env.bat. Check we've got pip installed, should already be installed, but we will check. So pip is basically a kind of installation package. Oh, in fact it is updating. There we go. So pip is now installed and upgraded. And then we're going to install a Python module called PySal. And you'll note we've got some extra bits here. So basically we're saying use Python 3 pip to install PySal, but version 1.14.3. And I think the user flag on the end here is just installing it for my user as opposed to universally. So the reason we're only installing 1.14.3, there is a newer version of PySal available, but the code changes slightly with each version, and the hotspot analysis plugin at its current state is set up to work with 1.14.3 and won't actually work if we install the more recent versions. So that might just take a few seconds to run and install. There we go. Now that may have taken a minute for you because there are actually a few other dependencies that get installed along the way. but now we have PySal installed. Now I'm actually going to close down QGIS for a second and relaunch it just to make sure it picks that up. So search for the Hotspot Analysis plugin. Now you see that I still have an error popping up, and the reason for this, as outlined further down the installation, is for some reason the Spreg functionalities of PySal generate import errors. So you don't need to worry too much about what this means, but what it does mean is that we need to edit a bit of code to sort it out. Okay, so the place to find your PySal installation should be your C drive, users, your user account, app data, roaming, Python, Python 37, site packages, and then you should have the PySal folder. So what we need to do is actually edit this __init__.py, the initiation file for the plugin. So if we right click, edit with idle, and what we're actually looking for is, you should see at the bottom right here, it gives you the line number that you're on. So it should just be this line here, line 95. And if we just add a hash at the beginning, that basically turns that into a comment and means it won't be run. Click Save, close that down, and if we now uninstall the Hotspot Analysis plugin. Okay, so we're now getting an error. PySal has no attribute common. So I think this is linked to this section here where it is trying to import bits from Pandas, which we don't actually need. So I think we can comment this whole section. So we're looking here at lines 43 to 48. So let's save that. So now that we've commented out those sections of code that should be causing problems, we can come back to the plugin. If you haven't already, close down and reopen QGIS to kind of try and avoid any issues there, and install plugin, and this time our Hotspot Analysis plugin installs with no errors, which is exactly what we want it to do. Okay, so now we've got that installed, we can start to look at how we use it. So I've set up some data. So the original question that I had was actually with the COVID-19 data, whether we could look at statistically significant hotspots. And the answer is, on a global scale, it has issues because of the spacing between countries. So what we may have to do, and I'm just going to do this fairly quick and dirty, is to select countries that are slightly closer spaced than others. Ooh, helps if I select the layer first. And I'm going to actually save these selected features to a new shapefile. And I've done this once when I was practicing, so I'm going to call it Cases Eurasia 2. Okay, that's not exactly Eurasia, but that's what I'm going to call it for now. So I now have a new layer that has these polygon shapes, and basically the Hotspot Analysis plugin requires us to have values within each point or area to calculate the hotspots. So as I'll show you in a minute, if we just have simple clusters, it can't work with that. We have to do some pre-processing for it. But in this case, we have our country polygons, and each of these polygons has values associated with it, in this case linked to the numbers of COVID-19 cases. So we can click here to launch the Hotspot Analysis plugin. We have a couple of different techniques. I'm going to stick with the local Getis-Ord Gi start, which I think is the right way to pronounce it. Input layer is cases Eurasia 2. My attribute field, so these are the values we're going to use to calculate the hotspots. So I downloaded this a little while ago now, so I'm going to use the case data from the 19th of April. And I'm going to leave everything else with the defaults. And I'm going to call this, just checking that I've not already called something yet. Call it Eurasia Hotspot, if I can spell properly. And click OK, and it might take a minute to run. Oh, just a few seconds. File is generated successfully, and we can see that we now have a map showing statistically significant hotspots. So within this entire area, it's picked out essentially kind of most of Western Europe as a hotspot, with kind of Spain, Portugal, France, Italy in the 99% confidence. UK down in 95%, and a few other countries picked out at 90% confidence. So there we go. We have now successfully generated statistically significant hotspots using the COVID-19 data. Now, just a quick addition if you want to work with point data. If I just open up some crime mapping data. So I've downloaded here crime occurrences for London. I can't remember exactly which time period it was now, but so each of these points represents one crime. So as I said, this plugin won't kind of spatially bin these for us. So if we want to actually create hotspots from this data, then we're going to have to do some pre-processing. So essentially what we're going to need to do is create a grid. So we can do that using the processing toolbox, and you can activate it, processing toolbox. And if we just type grid, we have the create grid tool. So we're going to want to create a polygon grid. We can do rectangles, diamonds, hexagons, exactly which shape, doesn't matter in any way. We can set the grid extent. The easiest thing to do if you've already got the point layer is to use layer extent and actually set it to the same extent as our crime data. And then you can set your spacing. So I'm using British National Grid coordinates, which are projected coordinates in meters. So I'm going to create a 100 meter grid. I'm not going to do any overlay. Here's my coordinate system, and I can either save that or save it as a temporary layer. So I've actually already created a grid, so I'm not going to hit run. I'm just going to close that. So what I've created is a layer that looks very much like this, so 100 by 100 meter grid across my area of interest. If I want to, I could just make the fill color transparent so we can actually see the layer underneath. So there we go, that's my grid. So what we want to do next is actually count the number of points in each of our 100 by 100 meter polygons. So actually what we're going to do is search count and use the helpfully named count points in polygon tool. So our polygons are our 100 meter grid, our points are our crimes, we don't have a weight or class field. We're going to call the field num-points, number of points. Obviously you can change that to whatever you want, and you can either save it as a temporary layer or save it as a permanent output. And then click run. And again, to save a bit of time, I've done this already, so I'm going to skip the run stage. And what this creates is something that looks exactly the same, but if we look at the attribute table, we'll see we have a count for the number of points within each of our polygon areas. And actually, if we wanted to, we could visualize this on its own using our num-points field mode. If I played around a little bit with the visualization tools, we could get nice hotspots, but I'm not going to worry for now because that's not the main focus of this tutorial. So now we have those grid squares with the count of points within each one. Again, we can now use the hotspot analysis tool. So I'm going to use Getis-Ord Gi star again. This time my input layer is going to be my London crime grid 100 meter count, and attribute field is number of points. Again, I'm going to leave it with the default, and I'm going to call this one Crime Hotspots London. And click OK. And this time it may take a little bit longer to run, as we've got a much larger number of polygons than we did when we were doing the country analysis. So although our spatial area is smaller, we have a much bigger number of points to consider, so we'll just need to be patient for a few minutes. And there we go. We now have our hotspots generated, and we can see in this case we have quite a few hotspots, no cold spots, and we can overlay that on our map. So there you go. That's how to use the hotspot analysis plugin within QGIS to calculate statistically significant hotspots across an area. So I hope you found that useful. If you did, please do like and subscribe, and keep your eyes peeled for more videos in the future.